Welcome to this explainer. Today, we're totally flipping the script on everything you thought you knew about materials science, plastics, and paper. We are diving deep into some seriously cutting-edge innovations from a company called Wuxi Hand Rigid. They are literally rewriting the rulebook on how everyday products are designed, manufactured, and recycled. So if you've ever wondered how modern manufacturing manages to balance extreme, industrial-grade durability with actual real-world environmental responsibility, well, grab a seat because you are in the exact right place.
Now, I want you to really think about this question as we go through today's material. How on earth does a single material redefine everything from a high-end hotel menu to the literal chassis of a high-powered AI PC? It sounds completely impossible, right? I mean, the structural, heat-resistant demands of a computer are just worlds apart from a piece of paper holding a wine list. But as we're going to see, the insane versatility of next-generation polymer technology bridges that exact gap.
Okay, let's quickly map out our roadmap for today. First, we'll meet PP synthetic paper. 2, we'll break down its 7-dimensional performance matrix. 3, print and decor applications. 4, high-tech industrial solutions. 5, decoding CMF with PO film. And finally, number 6, the Wuxi Hand Rigid Advantage.
Kicking things off with Section 1, meet PP synthetic paper, redefining material science.
Look, we're not just talking about some minor product tweak here. We are looking at a massive architectural shift in global manufacturing. Wuxi Hand Rigid is really the pioneer of what we can call sustainable futurism. They're taking advanced polymer technology and blending it seamlessly with strict ecological responsibility. It's all about creating materials for advanced industrial design that don't force manufacturers to choose between having a premium quality product and protecting the planet. Now, you actually get both.
Moving right along to Section 2, the 7-dimensional performance matrix, or, as I like to call it, engineering superpowers.
So, what actually gives this stuff the edge? Well, this brilliantly illustrates exactly why traditional materials are kind of just being left in the dust. PP synthetic paper isn't just good at one specific thing. It operates across a 7-dimensional performance matrix. Normally, you've got a compromise, right? If a material is highly printable, it's usually pretty fragile. If it's chemically resistant, it's often super heavy. But here, we're looking at a single substrate that manages to balance high-end printability, customization, and extreme chemical resistance all at the exact same time.
Let's really punch in on these stats for a second, because this is where the ESG, the environmental, social, and governance win, just becomes a no-brainer. Think about harsh environments that would instantly destroy normal paper. This material has basically zero water absorption, meaning it totally thrives in high humidity or literally underwater. It's impervious to acids, alkalis, and oils. It's got crazy high tear and fold resistance, which massively extends its life cycle. And on the logistics side, it's incredibly lightweight, so you're actively reducing transport costs and emissions. Oh, and crucially, it's highly recyclable, taking the heavy burden off timber and tree harvesting.
All right, Section 3, print and deco applications, focusing on everyday versatility.
Okay, so we've got the raw specs down, but where are you actually going to run into this stuff in the real world? Think high-end hospitality, for example. The absolute surface flatness and waterproof nature of PP synthetic paper create these vibrant, basically indestructible menus and art prints. It holds onto those bright, punchy colors flawlessly while remaining completely oil-proof and waterproof. If you're running a hotel or a restaurant, this fundamentally upgrades your customer's experience, and it totally eliminates that annoying, costly cycle of constantly reprinting worn-out, stained menus.
But it doesn't stop at menus. Let's scale this up into home decor and building materials. Under specific fabrication requirements, PP is quickly becoming the definitive alternative to PVC. And why should you care about that? Well, traditional PVC can be highly toxic to produce and an absolute nightmare to dispose of safely. By using just a 0.08 millimeter white film layer of PP synthetic paper, manufacturers can get a flawless reproduction that allows for hyper-realistic wood grain on cabinet doors and flooring. I mean, it is visually indistinguishable from natural wood veneers, but is infinitely more sustainable. Next up, Section 4, high-tech industrial solutions, where we're dealing with sub-millimeter stakes.
Let's shift gears for a minute. When you're in an environment where precision is literally everything, the manufacturing process has got to be bulletproof. This sequence maps out that high-temperature resilience process. It starts with the T-die melting flow, which is this highly advanced extrusion method pouring directly onto the PP substrate. It then moves right through a lamination station that demands extreme thermal resistance, then into a curing oven to permanently lock in the form factor, and finally through cooling and separation.
This incredibly strict thermal gauntlet is what ensures zero defects. And in heavy industry, zero defects isn't a nice-to-have, it's a non-negotiable compliance mandate. Now, what's truly mind-blowing to me is the sheer range here. On one side of the spectrum, you've got precision labeling. Think of the little sealing label on a pack of wet wipes or pharmaceuticals, where gloss adjustment and perfect surface flatness are absolutely key to keeping the product sterile inside. And on the other side, the exact same mastery of material science is being used in wafer chip and lead frame packaging for semiconductors. So from a baby wipe in your car to the microchips powering the smartphone in your pocket, the foundational material science solving the problem is exactly the same.
Let's zoom in on those semiconductor requirements for a second. Why are they trusting PP synthetic paper to protect the fragile global semiconductor supply chain? First off, it's ESD safe, meaning it actively prevents electrostatic discharge that would instantly fry a delicate microchip. Second, it has absolutely zero powder shedding. That completely eliminates particle contamination in those strict cleanroom environments where a single speck of dust is literally a disaster. And finally, its extreme flatness prevents microabrasions during the intense vibrations of international shipping. Like I said, sub-millimeter tolerances aren't a luxury here, they are the absolute baseline.
All right, Section 5, Decoding CMF with PO film, bringing mass manufacturing into reality.
So how exactly do we take all this high-level material science and actually apply it to the sleek, curved shapes of the electronics and cars we use every day? Well, first, we need to decode CMF, color, material, and finish. Think of this as the design blueprint that dictates a product's soul. Color defines the vibe and function. Material dictates how premium it feels in your hand. Finish cements the entire brand identity. CMF is essentially how a designer's abstract aesthetic strategy translates into a physical, tangible object you can actually touch.
And this is where things get really cool. Wuxihan Rigid's polyfilm, that's polyolefin film, is essentially the bridge that takes that CMF blueprint and makes it real. It captures the design strategy and translates it into a mass manufacturing reality using a technique called out-mold decoration, or OMD. In simple terms, OMD allows these highly advanced films to seamlessly wrap and bond those layers of color, material, and finish directly onto a physical base. It literally transforms a basic, boring plastic shell into a highly premium product.
Let's look at a massive trend right now to see this in action: AI PCs. As you probably know, AI computing runs incredibly hot, which creates massive thermal bottlenecks. To deal with that, the chassis needs to be metal or metal-like for high rigidity support. Now, the old, traditional manufacturing way would use highly toxic anodizing and spray painting to get that premium metal look. Wuxihan Rigid's PO film solution completely flips the script. It achieves a flawless metal-like texture on a plastic and alloy hybrid base, allowing for an 8:2 alloy to plastic ratio. This drastically cuts down the weight of the laptop while providing a totally green, low VOC alternative. Less volatile organic compounds off-gassing into the atmosphere is a huge win for everyone. And if we peel the onion back a little bit more and look at the automotive world, especially EVs, we see PO film actually replacing genuine wood and carbon fiber inside the cabin. They use something called TOM technology, which applies heat and vacuum pressure to mold the film, achieving flawless 3D wrapping over those really complex, curved ergonomic interior panels. It massively reduces the weight of the vehicle and the cost of the parts, while eco-friendly PP and PO materials ensure the car complies with really strict automotive green standards. Honestly, the next time you get into a modern EV, that beautiful luxury wood finish might actually just be a massive triumph of Wuxihan Rigid's sustainable polymer science.
Finally, Section 6, the Wuxihan Rigid Advantage, where scale finally meets precision.
As we wrap up the explainer today, you've got to ask yourself, who actually has the infrastructure to pull this off on a global scale? Well, Wuxihan Rigid currently operates China's largest PVC rigid film production base, and they are seamlessly pivoting that massive capacity into advanced PP and PO manufacturing. But as we know, scale means absolutely nothing without precision. They are utilizing state-of-the-art German KKA machinery, all housed within Class 100,000 cleanrooms. We're talking incredibly strict, hyper-sterile environments. That level of investment and infrastructure is exactly what guarantees that zero-defect production across the building materials, medical, food packaging, and industrial sectors we've talked about today.
Which brings us to one final thought. We've just seen how a single, incredibly eco-friendly material can literally protect microscopic semiconductors, replace toxic heavy metals in high-powered AI computers, and beautifully replicate natural wood in luxury vehicles. The tools to co-create a more beautiful, greener product future aren't years away. They are already right here.
The only question is whether modern industries are finally ready to abandon their outdated, toxic methods. So how will you leverage the next generation of sustainable material science? You can discover more about these game-changing solutions straight from the source by heading over to www.hanrigid.com. Thank you so much for joining me for this explainer, and keep learning.